Hi everyone, let's look at the questions from exercise 2.1 today. So the first question is find the principal values of the following inverse trigonometric functions. Right? We need to find the principal values. So what do we mean by a principal value? Principal value are the values in the principal branch of that particular function, right? So this is known as the principal branch. So a sine function, as you might have read before, a sine function goes from a real domain to anything between -1 to 1, right? So to restrict, if you try to invert this, it will not be an invertible function. You will not be able to get a 1 to 1 or an on to relation when you invert this function, right? So instead what we have done is we have defined a parameter. We have defined the range as only between -pi/2 to pi/2, such that we are only able to get these two. We are able to make it as a 1 to 1 and on to function, so that we can invert it, right? So that's the reason we get something called a principal branch. So we can take multiple such ranges here, right? So it's not fixed to this particular range. So, but we have defined a principal range called a principal branch, and the principal value is within something in this branch. So this is the table you need to be able to memorize and remember for you to be able to very quickly adapt and find out the answers to these questions, right? So we need to find out what is sine minus half, sine inverse of minus half. So what do you do here? You need to understand that sine of half. So there are multiple ways to solve this, right? So you could understand. So you know that sine 30 or sine pi by 6 is 1 by 2. So this means sine inverse of 1 by 2 will give you pi by 6. But we need sine inverse of minus 1 by 2. So pi by 6 is over here, right? So this is pi by 6. So let's say this is about pi by 6. So if you want to get minus half, so sine is positive in which quadrant? You know the acronym all silver teacups, like all silver teacups. So sine is negative in the second quadrant. Sorry, sine is positive in the second quadrant. Right, so sine is positive in the first quadrant and the second quadrant. So this is the third quadrant. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant, right? So sine is positive in these two quadrants and negative in these two quadrants. So sine minus half would belong to either this quadrant or this quadrant. But since our principal value goes from minus pi by 2 to pi by 2, so this is 0, right? So our principal value goes from minus pi by 2 to pi by 2. Right, so our value has to lie in this range, only in this range. So since pi by 6 is half, a negative, the reverse of that, or minus pi by 6, would also give you the same value but in the negative direction, right? So the answer would be minus pi by 6. That's an interesting way to get the answer, right? So this means sine minus half will give you minus pi by 6. So you need to think through the problem in a clear and concise way, such that you can get to this very logically, right? So now we need to find cos inverse of root 3 by 2. So let's try the same procedure, right? So first we'll try to say where cos is positive, right? So all silver teacups. So that means sine and cos both. So cos is positive in these two quadrants and negative in these two quadrants, right? Well, let me take a different color. Okay, it's okay. Positive in these two and negative in these two, right? So we know that cos 30 or cos pi by 3, right? You want to say it's cos pi by 6. Cos pi by 6 is root 3 by 2. You know this, right? So I hope you know that which trigonometric function is equal to what, at least in the pi by 6, pi by 4 and pi by 3, pi by 2 ranges. So you need to know that. So cos pi by 6 is root 3 by 2. So this means, this is very simple, so you can directly get the answer. This means pi by 6 equals cos inverse of, this means pi by 6 equals cos inverse of root 3 by 2. So here, since it's a positive value, we don't have to think much. So we directly get the answer as pi by 6. And we're done there. Right? Let's go to the next one. Right. So we have cosecant inverse of 2. Okay. So again, we know that all silver teacups. This is tan and cosecant, right? So cosecant and secant are positive in this quadrant. So it's positive here and positive here, negative here and negative here. So we need to get the answer either in this quadrant, the first quadrant, or the fourth quadrant. So cosecant inverse of 2. So what is sine pi by 6? So if usually you don't remember the values of cosecant, so the easier way to do that would be to remember the values of sine, right? So sine pi by 6 gives you 1 by 2. So this would mean cosecant pi by 6. So cosecant pi by 6 would give you 1 over 1 by 2, which is 2. So this means cosecant inverse of 2 would give you pi by 6, right? That's it. That's all it is. So since it is directly giving us the answer, so we don't need to worry about anything else over here. We don't have to think about other quadrants. So we directly can say the answer is pi by 6. Right. So this question says tan inverse of minus root 3. So now first thing we need to do is remember the where it's positive and negative, right? So tan is positive in the first and third quadrants, right? So tan is positive here, positive here, negative here, and negative here, right? And the tan inverse range and domain. So tan inverse goes from, so tan inverse function is defined from all real numbers to minus pi by 2 to pi by 2, right? So all real numbers to minus pi by 2 to pi by 2. So we need to find a value of, we need to find an angle between these values which is negative, right? So it's either going to be in the first, so minus pi by 2 is here and pi by 2 is here. So our value is only going to be lying in these two brackets, and this is positive, this is also out. It's only going to lie between 0 to minus pi by 2, right? So minus pi by 2 to 0 is the only range we need to look at. Now it is minus root 3. So we know that tan pi by 3 is root 3, right? So usually what happens in trigonometry is when you have a value in this quadrant, and you know that this is equal to pi by 3 and this is equal to root 3, the negative value usually happens to be the exact mirror image, right? So exact mirror image of this over the x-axis and just in the opposite direction, right? So this would give you minus pi by 3, and usually that's how it works. So tan minus pi by 3 will give you a minus root 3. So this would mean tan inverse of minus root 3 in the principal branch will give you minus pi by 3, and that's how we can do that. Great. So now this question talks about cos inverse of negative half, right? Now again, first thing we need to understand is which quadrants it's positive and negative. So cos is positive in the first quadrant and the fourth quadrant, negative in the second and the third quadrants, right? And we need to always remember, this is what this whole exercise is meant for you to be able to remember these values, right? So cos inverse is defined from minus 1 to 1. So it takes inputs of minus 1 to 1 and it gives you angles between 0 to pi. So this is 0 and this is pi. So since our value here is negative, so we need to find an angle between pi by 2 and pi. Now we know that cos pi by 3 is half. So pi by 3 is over here. So pi by 3, right? Pi by 3 is somewhere over here. This is pi by 3. Now the idea, and we know from the ideas of trigonometry that angles which sum to pi, right? So cos pi minus pi by 3 will be the same value as cos pi by 3. So pi by 3 will be same as pi minus pi by 3 for cos. It's not the same for all the trigonometric ratios. For cos, this happens to be the case. So cos of pi minus pi by 3 will be the same as pi by 3. The absolute value will be the same, but the value it becomes the opposite, right? So cos pi minus pi by 3 will be somewhere over here, right? So this will be 2 pi by 3. So this is 3 pi minus 2 pi is 2 pi by 3. Will be minus half. So in this area, we get pi by 3 is negative, which is 2 pi by 3. 2 pi by 3 is what you need to get. So now this would be equal to, this would mean that cos inverse of minus half would be 2 pi by 3. And that is what you need to find. So cos inverse of minus half is 2 pi by 3. Great. Now again, same rule, right? So let's find out. So tan is positive in the first quadrant and the third quadrant, negative in the second and the fourth quadrant, right? And tan inverse is defined from all real numbers to minus pi by 2 to pi by 2. So right, we need to figure out a value between these ranges. Now we know that this is pi by 2, this is minus pi by 2. And we know that the value is negative. So our value lies between 0 and pi by 2. Right, so now what do we do? Now we know that tan what is equal to 1. Tan 0 is 0, sin 0 is 0. So tan 90 is infinity. But tan 45 is what gives you 1, right? So tan pi by 4 is 1. Right, so that's tan 45. Tan pi by 4 is 1. So this means tan inverse of 1 is pi by 4. So similarly, we learned from last time. So we know that this is pi by 4. So pi by 4 is giving you 1. So negative would give you what? Minus pi by 4. So this works in x-axis. It doesn't work on the y-axis, right? So this would mean that tan inverse of minus 1 is minus pi by 4. That's simple as that. That's it. Okay, let's look at this question. So now secant inverse of 2 by 3, 2 by root 3. So always start with understanding which is positive, right? So secant is positive in the first and the fourth quadrants, negative in the second and the third quadrants. Now, we also need to know that secant inverse is defined from all real numbers except minus 1 to 1 range, and it gives you all values in between 0 to pi except for pi by 2, right? Now, if this is the case, then our value lies between 0 and pi by 2, right? Because this value is negative, we don't have to worry about this. So it lies between 0 to pi by 2. Now, we know that cos pi by 6 is root 3 by 2. So this would mean secant of pi by 6 would be 2 by root 3. Now this has made our life very simple. So now we just need to take the inverse here, right? So this would mean pi by 6 would give you secant inverse of 2 by root 3. This is directly giving you the answer which we are lucky. So this answer is pi by 6. But in case you always follow the drill and you'll always get to the right answer very quickly. Right? Let's go to the next one. Okay, we have cot inverse of root 3. Now again, so cot is positive in the first quadrant and the third quadrant, negative in second and fourth quadrant. So, and we also need to know that cot inverse takes values from R and gives you values between 0 to pi, I think. Yeah, between 0 to pi. So this is 0 and this is pi. And since our value is positive, we only worry about 0 to pi by 2. And this is, again, remember, this is the principal branch. It can be in many other different values, but we need to only find the principal value. So between 0 to pi by 2, there's a cot inverse of root 3 where the angle lies, right? So we know that tan pi by 3 is root 3 and tan pi by 6 is 1 by root 3. So this would mean cot pi by 3 is 1 by root 3 and cot pi by 6 is root 3. This is directly given as our answer, right? So if you just invert this, you get cot inverse of root 3 is pi by 6. So this would mean the answer of cot inverse of root 3 is pi by 6. So the answer is pi by 6. Right? So answer is 30 degrees. That's it. That's all the answer is. Again, always start with your quadrants. So we have positive here, negative here, and positive here. So next, what do? We always recollect the range, right? So cos inverse goes from, it takes values from minus 1 to 1, which is the domain, and it gives you values between 0 to pi, which is its range, the principal range, principal branch. This is 0, this is pi. This is pi, by the way. And if it is cos inverse of minus 1 by root 2, so this is going to be somewhere in this place, right? So now we know that cos of what is 1 by root 2, it's 45 degrees, which is about pi by 4. So cos of pi by 4 is 1 by root 2. And as we saw before, if you want to get the reverse, you need to subtract pi with this value, right? So it will be pi minus pi by 4. I'm going to go fast from now. So it will be 4 pi minus pi, right? Which is 3 pi by 4. And that's all the answer is. That's it. Let's go to the next one. We have cosecant inverse of root 2, minus root 2. So now again, cosecant is positive here, sine and cosecant both are positive, negative here. And we know that cosecant inverse goes from R minus 1 to 1 and gives you values from minus pi by 2 to pi by 2 except for 0. Right? So it gives you all these values except for 0. Minus pi by 2 to pi by 2 minus 0. Now, so cosecant inverse of minus root 2. So cosecant inverse of minus root 2. So this is going from these values, right? So minus pi by 2 to pi by 2. So it lies somewhere in this place, right? So now we know that sine pi by 4 is 1 by root 2. This means cosecant pi by 4 would be root 2, right? So if cosecant pi by 4 is root 2, what would be minus root 2? So this is pi by 4. This will be minus pi by 4. That's it. So cosecant minus pi by 4 would be minus root 2. So this would mean cosecant inverse of minus root 2 would be minus pi by 4. That's it, right? That's all. Right, so in these questions, you need to find the addition. So you'll find multiple angles and add all of them together, right? So you need to be able to figure out much more quickly. So now the first one, tan inverse of 1. So what is tan 45, which is tan pi by 4 is 1. So which means tan inverse of 1 is pi by 4. So we know that tan inverse goes from r to minus pi by 2 to pi by 2, right? So minus pi by 2 to pi by 2. That's the range you want to find out. So the answer will be tan inverse 1 is pi by 4, sorry. Tan inverse 1 is pi by 4. Now what about cos? Cos inverse goes from minus 1 to 1 to 0 to pi. And let's write sine also anyway. Sine inverse goes from minus 1 to 1 to minus pi by 2 to pi by 2, right? So now we need to find cos inverse of half, minus half. Cos inverse of minus half. So cos is positive here, negative here, positive here, sorry, negative here, positive here. So we need to find somewhere in this range. So we know that cos of pi by 3, cos 60 is half. We know, and we have learned before, that if you want to find the reverse of cos, you know, find the opposite. So cos pi by 3 is half, right? So if you cos pi by 3 is half. So if you want to find the negative half, you need to find pi minus pi by 3. So which will be pi minus pi by 3 will be 2 pi by 3, right? So pi minus pi by 3 is 2 pi by 3. So this will be 2 pi by 3. Will give you minus half. And similarly for sine, what will you do? Sine goes from minus pi by 2 to pi by 2. So this value to this value, these two ranges, right? And this is again negative, so it will be over here. So sine half is what? Sine half is pi by 6. So negative will be minus pi by 6, right? That's it. You just need to figure out the opposite value. So this would be minus pi by 6. So we need to add all of these together. So what will be the LCM? The LCM of 3, 4, 6 will be 3, 4, 6 will be 12. So 4 into 3, 3 pi. Plus 3 into 4, 8 pi. Plus or minus 6 2s minus 2 pi. So total you will get 8 plus 3, 11 minus 2, or 8 minus 2, 6 plus 3, 9. 9 pi by 12 is what you will get. Okay, let's look at this question. So here we have cos inverse of half plus 2 sin inverse of half. Again, I guess pretty straightforward. So cos, what gives you half? So cos 60, which is cos pi by 3, gives you half. Right? So that means cos inverse of half is pi by 3. Similarly, sin inverse of half. Sin of what gives you half? Sin of 5 by 6 gives you half. So which means sin inverse of half is pi by 6. So this means your values are cos inverse of half is pi by 3. So pi by 3 plus sin inverse of half is pi by 6. So plus 2 pi by 6. This is going to give you 3 2 6, right? So by 6, 3 2 2 pi plus 2 pi. This gives you 4 pi by 6, giving you 2 pi by 3. And that's the answer. Let's go to the next question. Okay, this one seems a little different from what we've done until now. If sine inverse of x is y, then which one of these options is correct? If sine inverse of x is y. So what do we understand from this? We need to find out x is the range, x is the domain, and y is the range, right? So x is the input values of sine inverse. So sine inverse, what are the input values? So sine inverse takes values between minus 1 to 1 and it gives you values between minus pi by 2 to pi by 2, right? So it takes values, this is the domain, right? The domain is this. And this is the range. So it takes values minus 1 to 1 and gives you values minus pi by 2 to pi by 2. Now, here x, basically x is somewhere between minus 1 to 1 and y is somewhere between minus pi by 2 to pi by 2. Let's check the options. 0 less than equal to y less than equal to pi. No, that's not true. This is wrong. Right? So y is minus pi by 2 to pi by 2. Minus pi by 2 less than equal to y less than equal to pi by 2. Yeah, that seems right. 0 less than y less than pi. That's wrong. minus pi by 2 less than pi less than pi by 2. Almost correct, but it also takes the end edge case values, right? So it takes these two values and not excluding. This is also wrong. So answer is option B. That's why you need to remember. This exercise is all about making you remember the domain and ranges of the principal ranges of the inverse trigonometric functions. Great. So now let's look at this question. Tan inverse of root 3 minus secant inverse of minus 2. Again, basic question. So tan of what is root 3, right? So tan of pi by 3 gives you root 3. So this means tan inverse of root 3 is equal to pi by 3. Sorry, what have I done? Is equal to pi by 3. Now, secant inverse of minus 2 is what you want. So now what do we do for this? We need to figure out, right? So we need to figure out, anyway, we don't have to go to that extent, but anyway, this is just for your revision. Secant inverse takes values from r apart from minus 1 to 1 and gives you values from 0 to pi apart from minus pi by 2. Right? So now, and we also know that secant inverse, is positive first and fourth, and negative and 0. So we need to find somewhere between these two. We need to find it somewhere between these two values, right? So minus pi by 2 to pi by 2 range. So 0 to pi is what we need to find a negative value. So we need to find somewhere between this range, right? So it will be somewhere in this range. Now we know that cos of what will be 2. Cos of pi by 3 gives you 1 by 2. So this means secant of pi by 3 gives you 1 by 2. Now, from our previous understanding, we know that if you want to find the negative, so it means secant of pi by 3 gives you 2. So if you want to find the negative, what do? You need to get secant of pi minus pi by 3, right? So if you know that secant of pi by 3 is 2, if you find the negative, you will get this value somewhere, which is pi minus this value. So pi minus pi by 3 will be 2 pi by, it will be secant of 2 pi by 3. So secant of minus 2 will give you minus 2. So secant inverse of minus 2 will give you 2 pi by 3. It will be 2 pi by 3. Now if you put these back over here, so this will be equal to pi by 3 minus 2 pi by 3. This will give you minus pi by 3. And the answer is option B. Great. I'll see you in the next video.